Your redundant safety protocols, they might not just be failing to protect your assembly line. They might actually be the very thing breaking it. This is what we call the error paradox. It turns out by layering failsafe upon failsafe upon failsafe, we've inadvertently created this massive psychological trap of cognitive friction. And this friction, it basically forces the human brain, which is biologically hardwired for efficiency, to seek out shortcuts. So today, in this explainer, we're going to unpack exactly how precision engineering totally collides with the biological limits of our minds, and why adding more rules often leads to more accidents.
Okay, let's just dive right into this. Take a look at this number here, 80%. In these high-stakes industrial environments, we spend a massive amount of time worrying about, say, a malfunctioning robot or a faulty pressure valve. But the reality? When you look at studies of major disasters, we're talking from Chernobyl to the Deepwater Horizon, they show that roughly 80% of all accidents are actually caused by human error, not machine malfunction. Human error, 80%. That is an absolutely staggering majority, right? Which leads us straight to our core paradox. If our technical systems, our sensors, our computer-automated shutdowns, if they're all so incredibly advanced, why do our safety protocols keep failing us? Well, to answer that, we really have to look past the shiny, high-tech facade of the factory floor and look directly into the neurobiology and the psychology of the human operators who are actually running them.
Now, to ground these concepts, we really have to look at the tragic reality of what happens when these psychological traps are actually triggered. What you're seeing here is the devastating aftermath of the March 2005 BP Texas City refinery explosion. This disaster killed 15 people and injured 180 more. But as investigators from the Chemical Safety Board eventually found, this wasn't just some sudden mechanical failure. No, it was the direct result of systematic, human-driven psychological traps that had literally been brewing for years. Section 1. The Swiss cheese model. Peeling back the layers of failure. So, to understand how a disaster like Texas City even happens, we have to look way past the immediate technical malfunction. This right here brilliantly illustrates what's known as the Swiss cheese model. It was originally proposed by psychology professor James Reason. I want you to imagine your factory's safety defenses. So, the equipment, the procedures, the alarms, as slices of Swiss cheese stacked up together. Normally, if a hazard occurs, it hits a solid part of one of those slices, and boom, it stopped. But, as we all know, every slice has holes. And when the holes in our defenses perfectly align, that arrow of hazard shoots straight through every single one of our safeguards, and that's exactly when you get a catastrophe. Now, what's really fascinating about these holes is that they basically come in two flavors. On the left, we have your active failures. These are your frontline slip-ups with an immediate impact, like, say, an operator pulling the wrong switch or just ignoring an alarm. But on the right, well, these are the real culprits, latent conditions. These are hidden management decisions, things like understaffing, budget cuts, or just poor interface design. And they just sit there, totally dormant in the system for years, until an active failure finally triggers them. At Texas City, for example, BP had slashed budgets by 25% in 1999, and then another 25% in 2005. That created some absolutely massive latent conditions. Section 2. The heuristic trap. When expert intuition becomes dangerous. So how do those active failures happen in the first place? Let's shift our focus to the individual operator's brain. Now, in a highly complex system, we rely heavily on expert intuition, right? But let's look at how that played out as a dangerous heuristic trap at BP Texas City. On the day of the disaster, operators were starting up this massive 170-foot distillation tower called a raffinette splitter. The problem? The written procedures were entirely outdated. And because veteran operators had successfully bypassed these rigid rules in the past to prevent equipment damage, doing that just became the accepted workgroup culture. Their past successes created this really dangerous illusion of permanent safety. They were essentially relying on a mental shortcut, a heuristic, that basically whispered, hey, we've always done it this way and we've always been completely fine. Section 3, Fatigue and Cognitive Fixation, the Neurobiology of the Micro-Oversight. But look, culture is really only half the battle. We also have to talk about our physiological limits. We're transitioning now into how mental fatigue fundamentally degrades your spatial awareness, your reasoning, and your fine motor coordination. This BP disaster, it was literally a slow-motion car crash. Take a look at this timeline of the dayboard operator, who was in charge of monitoring the system. For 29 consecutive days leading up to the explosion, this guy worked grueling 12-hour shifts. He was averaging only 5.5 hours of sleep per night. His brain's ability to process complex, unexpected information was just deteriorating day by day. And that brings us to this crucial number right here.
43.5 hours. By the day of the explosion, that operator had racked up a massive sleep debt of 43.5 hours. Just to put that into perspective, according to Human Factors research, the performance degradation from that level of chronic sleep loss, it's basically equivalent to being legally intoxicated. His brain simply did not have the biological resources left to troubleshoot an abnormal situation. And that kind of sheer exhaustion leads directly to what's called cognitive fixation. You can think of it like intense mental tunnel vision. When you're severely fatigued, your brain hyperfocuses on a single symptom while entirely ignoring the root cause. At Texas City, the fatigued operators became completely obsessed with these minor pressure spikes in the tower. They fixated on relieving that pressure, but totally missed the fact that they had been pumping highly flammable liquid into the tower for 3 straight hours without taking a single dropout. The tower was literally overflowing into the blowdown stock, but because of cognitive fixation, they just couldn't see the big picture. Section 4. Normalization of deviance, the culture of error. Now let's zoom out a bit from the individual's exhausted brain and look at the broader organizational culture. I mean, why were exhausted operators allowed to work 29 days straight? Why were they using totally outdated procedures? Well, I want to highlight this incredible insight from sociologist Diane Vaughn. She says, in some social settings, deviance becomes normal and acceptable. It is not a calculated decision because the definitions of what is deviant and what is normative have been redefined. What she's saying is workers aren't these amoral calculators who wake up deciding to sabotage a plant. They are just conforming to a broken corporate culture where rule breaking is literally just seen as how we get things done around here. Which brings us perfectly to the concept of creeping changes. This is the invisible, slow accumulation of minor rule-breaking and accepted deviations over time. You see, disasters are rarely sudden. They are almost always the result of thousands of tiny, ignored warnings. It's kind of like a ship captain who leaves port with the cargo doors slightly open just once, and hey, nothing bad happens. So the next time, leaving them open is just normal. Over time, that standard of safety slowly creeps downward until eventually it triggers a massive catastrophe. And let's look at how this builds in other high-stakes industries. Because, trust me, this is definitely not just an oil and gas problem. Diane Vaughn actually coined the term normalization of deviance during her investigation of the 1986 Space Shuttle Challenger disaster. At NASA, technical failures with the O-rings were repeatedly noted, but they were ignored because, well, the shuttle had successfully flown with minor damage before. Intense production pressures pushed them to launch anyway. Ultimately, it was conformity to an incredibly flawed decision-making culture, not rogue, reckless actors that caused the tragedy. Section 5. Rethinking system safety, fixing the latent environment. So the big question, how do we actually break this cycle and fix these systemic issues? How do management and safety professionals go in and fundamentally repair these deeply embedded cultural and physiological problems? Well, take a look at this table. This is the Human Factors Analysis and Classification System, or HFX. Now, notice how level 1, the unsafe acts, right down there at the very bottom, is really just the tip of the spear. The operator pulling the wrong lever, that's level 1. But to stop that from happening, you can't just fire the operator. You have to fix level 2, the preconditions, like the operator fatigue we talked about. You have to fix level 3, the unsafe supervision that completely ignored that fatigue. And most importantly, you absolutely must fix level 4, the organizational influences, like aggressive cost-cutting, that forced the unsafe supervision in the first place. Long story short, you have to fix the top to cure the bottom. Ultimately, what we have to do is build what safety experts call a just culture. This means that we stop pointing fingers at the individual widget or the frontline worker who made a mistake. Instead, we hunt aggressively for those dormant latent conditions hiding out in the management structure. We have to create an absolute atmosphere of trust where workers can report near misses without the constant fear of punishment. And finally, we have to redesign our systems so they actually match human biological limits, rather than expecting humans to operate like flawless machines day in and day out. We've covered a whole lot of ground in this explainer today, from the Swiss cheese model to the really insidious nature of the heuristic trap and cognitive fixation. But I want to leave you with this final, somewhat provocative thought to apply to your own life and your own workplace. What creeping changes and normalized deviance are hiding in your own daily routines right now? What safety rules or best practices have you slowly started ignoring just because, well, nothing bad has happened yet? Take a moment to identify them today, before the holes in the cheese finally align. Keep learning, keep analyzing,